Section 1.3 of the textbook talks about the scientific method. The scientific method is something that you should see in Biology 1107 and most of your introductory classes, probably even physics, because of the fact that it's a fundamental center of how new discoveries are made. In a scientific method, you have an experiment, okay, which is an observation of a phenomenon. I'm not sure I agree with the word natural, carried out in a controlled manner so that the results can be duplicated or rational conclusions can be drawn. Okay, and then the result of those experiments, okay, typically leads you to a law, hypothesis, and theory. And while they have different definitions here, I like to think of the differences about them as being the age of them. Okay, so the very first thing that you create is a hypothesis, which is just a tentative explanation of something that you observe. Okay, and once you have a hypothesis and you go through the scientific method multiple times, then you can propose a theory, which has been tested to some extent. All right. So if you think about theories, okay, things like the Big Bang Theory was developed in the early 1900s. Okay. So it's a fairly young still. Okay. And the Big Bang Theory probably is very close to now being a law. Okay. And then, like I said, law is something that happens eventually, okay? And so it becomes a concise statement of mathematical equation about a fundamental regular relationship. And so if you can think about a law, okay, the law of gravity or Newton's law of movement, those are laws. Those are older. Those were obtained in the 1600s. And so basically, you can think about these things as different ages. Okay, hypothesis being the youngest, because it's what's formed at the very beginning. Once you do a series of experiments, then you can generate a theory. Okay, and once that theory has been tested and refined enough, then it will eventually become a law. Okay, and this can be very simple things. 3-year-olds, 2-year-olds, 3-year-olds make some of the best scientists because what do? They ask questions. Why does this happen? What's going on here? Why is this happening, basically? And so they observing what they see around them and they're asking questions. That's what scientists are going to do. So this next slide shows you basically what happens. Okay, so you see something occur and you ask, why did that happen that way? Okay, and you try to think of what are the possible reasons that this occurred. Okay, and based on those questions, you formulate a hypothesis. Okay, what do I think caused what I'm observing here? Okay, and then from there you do some testable predictions. Now, a good experiment you try to control so that only one thing in the experiment changes each time you run the experiment. Okay, and so I run that experiment and I gather data and test predictions. Okay, and this is a loop inside the loop. Okay, so once I do one set of experiments, I'm not done. I need to refine it, I need to alter it, I need to change it, I need to completely throw it out and think of new reasons. And then I come back and do another test, okay, and it comes back. So this cycle here can last in time for anything from, 6 months to a year to 5 years. You don't know how long this little cycle is going to happen. But basically from that, then you can develop general theories, okay? And those theories then can be applied to other observations to see if they hold true. All right. So let's think of a very simple experiment. Why does milk spoil? What might be effects of milk? Okay. So we store milk in the refrigerator, and the refrigerator is known for doing what? It keeps things cold. So we might think the temperature has effect. But what happens inside the refrigerator when we close the door? It also gets dark in there. So does light also play a part in how milk goes, how long milk does not go bad? Okay, so I have two different things that might be possible there. Okay, I have the light and I have the temperature. So what could be something that I could test? Well, if I have them both, if I have one setting outside and I have one sitting in the refrigerator, I want to make sure the light condition. So I can either make sure the light stays on inside the refrigerator, or I can make sure the milk on the outside stays in the light. Okay, so I want to make sure that the light's constant, whether it's in the refrigerator or if it's sitting out on the counter. Okay, and what about different temperatures? Can I do a warm room versus a cool room versus the refrigerator? Okay, so I can test multiple parts of that one variable, that's what it's called, which in this case would be temperature. Okay, if I want to test light, so if I keep both in the refrigerator, but in one experiment, temperatures of the two refrigerators would be the same, but in one, there would be a constant light on, and the other one would get dark. And you could go even further. You could say, does the type of container of milk play a part, and how long does it take to go bad? So that's just a very simple type of experiment that you might be able to think of. And that is the end of this section.